Okay, everybody, welcome. In this video, we are going to get rolling with creating scatter plots in ggplot2. So we maybe have done like a really brief introduction to that, but we're going to dig deeper into that process and talk about how we can customize those a little bit, add smoothers to scatter plots, add faceting to scatter plots, and how that's going to help us read them and search for lurking variables, identify confounding variables, etc. So that's the goal in this video. And the next couple ones will be kind of working with scatter plots, adding some additional features to scatter plots that are going to be useful when we're performing exploratory data analysis. So this video, as most of the videos, all of them, are going to require us to use some packages in R, in particular ggplot2 and the Palmer Penguins packages. So you're going to need to go back and run the first code cell in this notebook to install those packages, since it might have been a while since you started working in this notebook. So that code cell looks like this. It's way back at the start of this notebook. The packages that you're going to need in the next couple of videos are going to be the ggplot2 package for plotting, obviously. That's what we're learning in this video. Palmer Penguins has the data, and we're going to be using the GG themes package shortly to introduce color scaling. That's going to be a little more friendly, colorblind contrasting on our scale. Okay, so a scatter plot. This is a useful plot for looking for relations between two numeric variables. So in the previous couple of videos, we were looking at the distribution of flipper lengths. That's just looking at one quantitative, one numeric variable. And then we were looking at the relation between flipper length, say, and species. That is one quantitative variable and a categorical variable. So we introduced the aesthetic, the fill aesthetic, to introduce the categorical variable species into the plot. If we're looking at a relationship between two numeric variables, then a scatter plot would be a reasonable option for that. And so a scatter plot is good for looking at relations between, say, a predictor variable and a response variable. Does changing the value of one predictor variable, is that associated with a change in the value of some other response variable? So we plot the predictor variable on the x-axis, and we plot the response variable on the y-axis. And then we look for patterns in the points that are plotted in the scatter plot. If they're going up as we move to the right, then we say there's generally a positive association. If the points go down as we move to the right, then we say there's a negative association. And we might see some other sorts of associations, like maybe there's a quadratic association and they go down and then they go up, and we see like a parabola in our plot. So there might be an association which is not linear, that happens. Or there might not be any association at all, and we just might see like a big cloud of data. So those are some patterns that we might look for in a scattered plot. So before we get going with this, the Penguins data frame, if we take a look at it, and this is a good check to make sure you've got it loaded. If we run a structure command on, or the summary command on it, we run summary penguins, just recall that there are some missing values in this data frame. So if we're looking at, say, the relation between, in question 3, body mass and bill length, notice that body mass is missing 2 values. Bill length is missing 2 values. They may be the same 2 observations. They may be different observations. So if we try and create a ggplot with variables that have missing values, it will create the ggplot. It will give us a warning message. However, So in order to just avoid getting that warning message every time we create a ggplot, I am going to clean the penguins data as follows. So I'm going to run this code cell. And all this code cell does is it's going to say, let's keep the observations where penguins bill length. Remember, this kind of exclamation point is like the not logical operator. So this is saying, let's keep all of the observations in the penguins data frame that have bill length not equal to NA. And this operator is the OR operator. So this is saying, let's keep all of the observations that have bill length not equal to NA or body mass not equal to NA. So that's going to keep all of the observations except for these two and except for these two. And it happens to be the same two observations that have no bill length and no body mass. So this is going to get rid of two observations in the data frame. And now we won't get this annoying message that says there's two missing observations, or we won't have to include this option na.rm equals true inside of our plot every time to avoid getting that message. So that's the only reason why I'm doing that. If you don't run this code cell, your plots will generate just fine. You'll just get a little warning message. Okay, so to create a scatter plot, we're going to map the predictor variable to X. We're going to map the response variable to Y in the aesthetic. And then we're going to use the geom point. So question 3 is saying, let's use the penguins data to create a scatter plot. We're going to use body mass as the predictor, bill length as the response variable. So we're going to go ggplot. The first thing we do is enter the data that is in penguins. Then we need to enter our aesthetic mapping. This is saying we want the predictor variable to be body mass. So that's what we map to X. We want the response variable to be bill length. So that's what we map to the Y. And there is some autocomplete on these, which is nice. So that completes our first kind of part of this ggplot. So that kind of sets up our canvas. And then we need to tell ggplot what type of geom to use, what type of plot to create. And for scatter plot, we use the geom point. And there's a basic scatter plot for these two variables with body mass as the predictor variable and bill length as the response variable. And we can see from this plot that there's a positive association between these two variables. As body mass goes up, the bill length goes up. And this makes intuitive sense, right? Like as the penguin gets larger, as their body mass goes up, we might anticipate that they would have a larger bill. They would have just larger everything, right? Their proportions go up overall for everything. That's not like a hard set rule, but generally speaking, we would expect that. And we can see that in the graph. As we move to the right, the points go up. There is like a little hump of points over here in the upper left corner that seem to deviate from this kind of stronger association that we're seeing with the rest of the points. And so maybe these are outliers. Maybe there's some noise. Maybe somebody made a mistake when they were making their measurements. There could be any number of reasons why we're seeing this. But we've got some suspicions. There are other variables in this data frame, such as species and sex and island. And so maybe there's some other third variable lurking in the background, which is causing this other cluster of points over here. So we call that a lurking variable when it's unaccounted for. When we identify this in our analysis, it's called a confounding variable. So a confounding variable would be a third variable other than the predictor variable and the response variable, which is associated with both of those two variables. So a confounding variable is a third variable that's going to be associated with both the predictor and the response variable. Okay, so I'll take a break here in this video, and in the next video, we're going to use some additional aesthetics in our scatter plot to try and identify what might be some possible confounding variables explaining what's going on in this plot. Thanks, everyone.